Okay, so today what we're going to do is we're going to be finding real, we're going to call them roots, real roots, which are x-intercepts of polynomials. X-intercepts, sorry, that's sloppy. Okay, so we're going to find real roots, which is the same thing as x-intercepts of polynomials. I know this is an x cubed. I know it's a squiggly. It might cross the x-axis somewhere. Well, we're just going to factor. All right, well, if I take a look at it, I recognize if I can common factor, it makes the problem easier. You're totally right. If you can take out a 2x, which is what Redis said, makes the problem smaller, right? So if you can common factor, do so. So Redis says 2x, I totally agree. And when I take out a 2x, we get a x, minus a 6x, right? Plus 9.
You started without me this time?
I did. So then, can we factor again? Can we factor again? I think so. I know 3 times 3 can make a 6, right? A negative 3 would make a negative 6, so I'd go x minus 3 equals 0, right? I need to solve. So I'm going to take my mini equations. I call them mini equations. Set them equal to 0, right? So I've got a 2x equals 0. I have an x minus 3 equals 0. And an x minus 3 again equals 0, okay? Divide by 2. One of them is 0. I sure can, Retta, sorry. Yeah, no, please tell me to slow down if I get going too fast. Just because I can do it is not fair to you, is it? So while you're catching up, I just want to factor it. The key is I know there should be 3 answers. So I'm trying to get it in a factored form so I can find 3 mini equations. So I know there's 3 answers. What Retta saw was if we can common factor, then it makes the problem smaller. Took out a 2x. X squared minus 6x plus 9. And then I can then factor that, x minus 3, because those are the multiples of 9. And then I'm ready to start solving my mini equations. So I go plus 3, x equals 3, plus 3, x equals 3. Those are the answers. Now, you don't have to do this, but I'm going to show you anyway. This is what the graph looks like. Okay, the graph looks like, and you can put it in decimals if you don't believe me, but I know it looks something like this. This 3 occurs twice right there. Can you somehow imagine that because it just barely touches it, goes through it twice, goes through it, then back through it? So that's called a double root. We'll talk about that more later. But it does have 3 x-intercepts, even though this value happens twice. I didn't use decimals. I knew that the graph had to look like that. All right. Okay, how about example 2? What do you think? Good, let's do it. Let's make it easier. Let's take out a 4. I'd have a x to the 4th minus 10x squared plus 9 equals 0. Good. I agree. Can we factor again? Can we factor again? Can we factor again?
Yeah.
So, I'm going to go x squared. Does that make sense?
No.
And then probably 9 and 1. How come I'm going to go 9 and 1? Because that'll make it 10. How How about negative 9, negative 1, right?
Yeah.
Negative 1, negative 9. These two can be factored again. I can factor again. I'm going to factor again. So I'm going to go x times x makes x squared, plus 1 minus 1, right? And I'll do the same thing over here. I'll go x and x. I'll do a x times x, and I'll do a plus 3 and a minus 3. Now I should have 4 answers, and I'm going to get 4 answers. I will get, yes.
So when you factor it, like the one that you just did, do the other numbers, do they have to equal 0?
Ask that differently.
I mean, like, so you factored the negative 1 into a plus 1 and a minus 1?
Yes.
And then the negative 9 into a plus 3 and a minus 3?
Yes.
And then if you add...
Oh, do the double smiley.
Yeah, do they have to equal 0? Like
Yes, because there's an invisible x here and another invisible x here. Nice, yes. Nice job, Cassidy. Completely correct. So then I've got my mini equation. Now, first of all, the 4, watch. You guys look at the 4? There's only 4 answers. This 4, we could divide by 4, but the 4 does not have an x. You agree? So the 4 is not a mini equation. You could divide by 4, and get rid of it. But your mini equations are x plus 1 equals 0, x minus 1 equals 0, x plus 3 equals 0, and x minus 3 equals 0. And of course, solving this is pretty easy, right?
Yeah.
So I'd have x equals negative 1, x equals positive 1, x equals negative 3, and x equals positive 3. Now you're not asked to graph it, but this graph would look like this. This graph would look like this. If you graphed it, you have your 4, you can see them, you'd have your 4 intercepts, which are your 4 zeros. That's what we found. We found the x-intercepts, called the zeros. Yeah, that's what we found, were the x-intercepts. Okay, now example 3, since we're finding zeros, it needs to equal 0. Yes?
So the 4 on the outside is how many zeros there is?
No. Great. I'm so glad you asked that. The exponent of 4 tells you how many. The 4 on the outside just makes it taller. That's all.
So we don't even worry about the 4?
No. In fact, if I wanted to right at this step right here, I could have divided everything by 4, and it actually would have made the problem easier. It would have taken us right to there. Okay? Hi. Now, how about example 3? Well, we're finding zeros, so it needs to equal 0. So I'm going to bring... Yes, let's do this first, but I totally agree. Let's do this first. I want it to equal 0, so how do I bring over? How do I bring over the 14x cubed? How do I do that? Yeah, and let's put it in the right place. So I'd have a 2x to the 5th minus a 14x cubed plus a 24x equals 0. Now, who said the 2x? Who said the 2x? Yes, I agree. We'll do that next, okay? So now we're going to common factor. I agree with Giselle. We're going to take out a 2x, common factor out of 2x. I'll have a x to the 4th minus a 7x squared plus 12, okay? Equals 0. Okay. This will factor, yeah, that's exactly right. X squared minus 4 minus 3, right?
Wait. Oh, wait, yeah.
Why did you put the cube on the 24?
The color? Okay.
No, he was making it 0, so he had to like take it from the other side.
Okay.
Thank you. I was confused. Yes, that's exactly right. Now, I can factor this x squared minus 4 again, but I cannot factor the x squared minus 3. I can't. I could, but it would be like this. I mean, I could. I could go, it would be an x plus the square root of 3, x minus the square root of 3, but you're not going to see that, are you? Right, you're not going to see that? But we're going to get that answer by solving it, okay? All right, so, let me keep going. So, I put that phone away. You should be taking notes. So, let's factor this one again. 2x, x plus 2, x minus 2. And this can factor, but you're not really going to see it. It could be an x plus the square root of 3, x minus square root of 3, but let's just leave it as an x squared minus 3 for right now, okay? So you have many equations, right? You have many equations. We have 2x equals 0. I have an x plus 2 equals 0. I have an x minus 2 equals 0. And an x squared minus 3 equals 0.
What do the many equations do?
Right. So it gives us these answers. And I'm going to answer your question in a second. Okay. So before I go on to the next one. So if, and I should show this. If I were to plug negative 2 in for x, it will make the entire equation 0. If I plugged in 2 in for x into this equation, it would make the equation 0, because these are the zeros. So the mini equations are saying what value of x would make it equal to 0, right? And you know that if this is 0, then everything's 0, because 0 times anything is 0. So if it's negative 2, the whole thing is 0, right? If it's positive 2, the whole thing is 0, because 0 times anything is 0, right? Now, what about this one? Well, sure you do. Watch me do it, okay? We're going to solve. So if I have, I'm going to put it up here, x squared minus 3 equals 0. Let's solve it. Plus 3 plus 3. And then how do you do the opposite of an x squared? Square root it. How many answers should I have? I need 2 answers. So I get x equals a positive square root of 3 and a negative square root of 3. So I do get 2 answers. Okay. Square root of 3 times square root of 3 is 3. Negative times a negative is still a plus. So we get all our answers. Okay. That one's a little harder, but we are in Algebra 2. We're not in geometry. Okay, turn the page. So I get all of these answers. I get that one, and these 2. Yeah, I will. Yeah, the graph on this one would look like this. I'm going to have 0. I'm going to have negative 2. 0. I'm going to have negative 2. I'm going to have positive 2. And the square root of 3 is about 1.7. So I'm going to have a point at about 1.7 and negative 1.7. Since it's an x to the 5th, it's got to look like this. It's going to squeeze through there, through there, through there, and there. It's going to look like that. And we can put it on decimals and check. That's what it's going to look like. Honest. I'm smarter than a calculator. So are you.
Are you?
Yes, so are you. So are you. Okay? Sophia, how am I doing? Okay? Valeria? Okay, turn the page. Okay, now how about this one? How about this one? Well, let's bring the 16x squared over. Michael, you see what I'm doing?
Yep.
So it's equal to 0. It goes a 2x to the 4th minus a 16x squared plus 32. Okay, good. Now what?
Common factor of 2.
Yes. Now, can I show you another trick? Because it equals 0, let's just divide by 2, and then it's gone. It's just gone. You okay with that?
What?
Yeah.
Yeah, instead of common factor, and it only happens because it equals 0, right? Divide by 2, and it's gone. X to the 4th minus 8x squared plus 16, right? I sure can. So instead of common factoring out of 2, we can just divide the 2. Only because it equals 0, right? I mean, divide by 2 is gone. It's gone, right? Give me thumbs up when you're ready. Okay? I'm going to go x squared. Does that make sense?
Yeah.
And then what do you think? What times what makes 16? Negative 4, negative 4. Ah, negative 4, negative 4. Ah, negative 4, negative 4, right? Okay. All right. X squared minus 4 can be factored again. Both of these can be factored again. Into x plus 2, x minus 2. And again, right? X plus 2, x minus 2. Now, do I really need my mini equations? You guys okay with me just saying x equals negative 2, x equals 2, x equals negative 2, and x equals 2 again, right? Right? So what does this graph look like? Well, anytime you get a number that happens twice, it's called a double root. So it has to literally go through, watch. I'm going to do it up here so you guys can see. Watch. So it happens twice. This 2 happens twice. So it goes like this. Watch. Here's watching. Goes through it, and it goes back through it again. Goes, oh, that's lousy. Goes through it, and it goes back up. See how it goes through it twice in the same spot? It's called a double root. We can do it. We have big brains.
Actually,
Oh, yes, I'm so sorry. Please help me go slow, okay? All right. I know I get all excited about this stuff, and I can't help myself, but that's no excuse. It's no excuse. Okay, so you're okay with all my answers?
Yeah.
Madison, you good with my answers? And we don't have to graph this, but this number right here has to happen twice. You see it? So if we're to go through it twice, it goes through it hypothetically, goes through it again. So instead of going through, it goes through and back up, right? And here, instead of going all the way through, it goes through it and back up. Okay? Now, let's play Jeopardy. So I know that negative 3 is an answer to a mini equation. So if negative 3 was an answer to a mini equation, it had to have an x plus 3 equals 0 as its mini equation. Okay? And you can do that.
Yeah.
Right? Does this make sense? Watch. Yeah. If negative 3 was an answer, it had to come from x plus 3. All right? If positive 1/2 came as an answer, okay? If x equals positive 1/2, that means I would have had a 2x equals 1, and I would have had a 2x minus 1 equals 0. Okay, now think about this. If you solve this mini equation, wouldn't you get 1/2? If you solve this mini equation, wouldn't you get 1/2? And if x equaled a negative 1/2, it would have had to have had a 2x equals negative 1, or a 2x plus 1 equals 0, okay? So this mini equation would have made that. I will. This mini equation would have made this, and this mini equation would have made that. And I will slow down for a second, okay? Okay. Yeah, this should be
What am I on?
okay, now, you ready? Let me, go ahead.
No.
I'll let you write it down, and it'll make sense. It really will make sense.
I'm not even sure.
I know you have to do this.
But like everything I learn makes no sense. No, like it makes sense, but like
I'm just writing down numbers.
It makes a lot of sense.
We spent a lot of time just doing that. So you ready? I know this will be easy once I slow down and explain it, okay? Yeah, and I'm not done. We haven't put the answer down yet, but
Oh, we're not
waiting.
done.
Because what we'll do is we'll put them all together and make a polynomial. Just say, like I already said, we'll put all three together and make a polynomial.
What's it called?
It's like multiple monomials.
Okay, tell me when you're ready. Tell me when you're here, okay?
I'm here.
Okay?
Is that top
Is
one? Is that equal?
Let's play 21 questions.
Yes.
Okay, sorry.
So, if I'll wait for Valeria. I'm sorry, Valeria.
Good.
Come on, Mr. Baby, slow down, please. Okay, here it is. It's easy. I'm not kidding. It's easy. Watch. If -3 is an answer, you listen, then it had to come from this mini equation. That makes sense?
Oh, okay.
So you do it backwards. You do it backwards. You bring back over the 3, don't you? Right? You're doing it backwards. Well said. If
But don't we
1/2
need
was
4?
an answer, you would have had a 2x, bring it backwards, and then you bring over the 1. A 2x minus 1 mini equation would make 1/2.
I thought we needed 4.
We're going to have 3.
No.
This is third
Not
degree.
like the number 4, but like 4. X intercepts.
Not on this one. It says, what's it say right here?
Oh,
Third degree.
I just didn't read.
That's okay.
The third degree.
And then, if -1/2 is an answer, right? If -1/2 is an answer, it had to have come from a 2x plus 1, right? Yes. Not necessarily, it just means the degree 3. So I know that it would be an x cubed. It's an x cubed, okay? Great question. So then let's put it together. So what I have is these mini equations. It would have been this. It would have been, well, we had an x plus 3 times a 2x minus 1 times a 2x plus 1 equals 0, right? So I took these, these. So I'm recreating our polynomial. So there's some polynomial that we already factored. Then we made our mini equations and solved. We got our 3 answers. So since it's a polynomial, I'm going to go P of x.
So we're trying to find the equation for
The original equation. So the original equation was this. The original equation was P of x equals x plus 3 times 2x minus 1 times a 2x plus 1. And that is the equation that would have